So good morning, good afternoon, or good evening, depending on where you are located in the world. And thank you for joining us on this fine Wednesday, April 20th, 2022. Just waiting for everybody to join the webinar. So we'll just go through the introductions while everybody is joining. As always, if somebody could post in the chat bar to let me know that you can hear me, that would be appreciated. It really helps me out to know that people can hear me. So I'll just wait until I have somebody tell me that you can hear me. There we go, Brooke. Thank you very much indeed. So I can continue. So today we're going to be talking about increasing reliability in your machines by performing maintenance. But before we get any further, my name is Craig Williams. I'm the Senior Technical Manager for AMETEK Solidstate Controls, based in the Stafford office, which is just southwest of Houston, Texas. Can't you tell from my accent? I have 20 years in the industrial UPS industry. For my sins, yep, I used to work in the North Sea. I'm from Scotland originally, repairing and maintaining industrial UPSs in the North Sea oil and gas industry. I've worked with the majority of the major UPS charger and manufacturers, so I'm familiar with many different designs. Regarding the webinar, there will be a lag of around 30 seconds between you hearing my voice and me seeing a question or a comment in the chat. Basically, Webinar Jam has to convert all of the signals into iOS, into Android, and into Windows-based operating systems, and to do that there is some processing time. So when I speak, you get to hear it approximately 15 seconds after I actually do speak. So therefore I'm going to see the comments 15 seconds after I've said something. Hope that makes sense. The platform that we use is Webinar Jam, and it has a panic button, and basically what that means is if something goes wrong with the webinar, then I can press the panic button. Everybody will be kicked out of the room that we're in just now. A new room will be started. Everybody will be invited back into that room, and we will start from where we left off. A very popular question is, will the webinar be recorded? And yes, we always record the webinar. It will be broadcast in two ways. First of all, if you have a registration for the webinar, you will receive a link after the webinar where you can go and watch the webinar again through the Webinar Jam platform. Unfortunately, that recording, once you press play, you have to watch from start to finish. You can't rewind, fast forward, pause, do all that kind of stuff. I think you can pause it, but you can't rewind, fast forward, and go to the parts that you are most interested in. But what our marketing department do, the fantastic marketing department that we have, is they will convert that file into an MP4, and then they upload it to our AMETEK SCI YouTube channel, which will be done tomorrow, and you can view that video and rewind, fast forward, and do whatever you want. And you can share it as well. It is a publicly open webinar that you can share. And the last thing, the webinar should last around about 1 hour, depending on how much I speak. I think I stayed on track last month, which was a miracle. I usually do go over, but I do try and make it stay around about an hour. Okay. So today, the objectives are: understand why you should perform maintenance, understand what maintenance should be performed, understand why the recommended maintenance time intervals were created, and then discuss the use of the specialized equipment during the maintenance. Okay. And before we go any further, most plants will have an engineer that is specifically tasked with reliability, a reliability engineer. I am in no way a reliability engineer. Most of the information on these few slides that we're going to go through in a moment are taken from the internet, are information that's been passed down from me from people who know what they're talking about. So it's just to give you an overview of why we should perform the maintenance. And obviously, the biggest part of that is to ensure the reliability of your equipment. Best case scenario is to get it up to 100%, so it never fails. Unfortunately, that's wishful thinking, that there are always going to be failures somewhere down the line in whichever piece of equipment it is that you're going to talk about. And as we know, uptime equals increased safety, because whenever you have failures, you have to send your electricians or your technicians out to the UPS or to the equipment and try and troubleshoot and find out what's going wrong. And we all know the plant is usually in a panic when a UPS fails or goes into alarm. So that there are pressures that are put on the technicians to try and fix that system as quickly as they possibly can. And unfortunately, that can lead to accidents in the workplace. It shouldn't do, but you know, human error is one of those things. So you know, the more uptime you have of your equipment, the increased safety you're going to have, because people aren't going in and trying to find out what's wrong with the system. And obviously, there is financial implications on that as well. The more uptime your UPS has, the more money that you save, because the production process that the UPS is protecting doesn't get disrupted. So safety is very important, and then the financial implications are there as well. That's why we want to try and keep the uptime of the UPS as high as we can. So here's actually a very good graph that is widely available on the internet, and it's what a lot of reliability engineers use to show why planned maintenance is so important. So if you see here, at this axis here, this is pretty much 0. That's when the maintenance frequency of planned maintenance is 0. So you're not doing any planned maintenance. And right here, that's when you're doing lots of planned maintenance, maybe too much planned maintenance. And this red line here is what we're talking about, planned maintenance. And then the blue line here, as you can see, is corrective maintenance, and the green line is the total cost. So as you can see, if you're not doing any maintenance on the left-hand side here, the total cost, which is the green line, is at its highest. What they're saying is you're not doing any planned maintenance, so the corrective maintenance is at its highest at that point and costs a lot of money. And then as you move to the sweet spot, which is this point here, that is when the planned maintenance goes up to a suitable level where you're in this sweet spot of the curve where the total cost and the corrective maintenance is going down, is at its lowest point. Okay, so that's the sweet spot we want to get into. And then as you can see, this section here is where we're doing lots of planned maintenance, which means the cost of that maintenance goes up. But you can see that the return on the corrective maintenance doesn't change much in that area. So we really want to stay out of this area, and we want to stay out of this area. This area here, the optimum PM frequency, is what we're looking for. And unfortunately, I can't tell you what that optimum level is for your plant. That is why your reliability engineers are there, to try and find out what is the sweet spot for your plant and how much planned maintenance you should perform. Okay. Now, this graph is also quite telling. On the left-hand side is what they call a challenging example. In other words, a plant where most of their maintenance is reactive. They may have a run-to-fail kind of maintenance schedule. They're only doing 36% planned maintenance, and therefore 64% of their maintenance is breakdown maintenance. And the important thing to remember is what it says at the bottom there. One planned maintenance hour is worth 2 breakdown hours. And if you see the writing below that, many think one planned maintenance hour is actually worth closer to 3 breakdown hours. Because if the production delay is planned, the machine operators can be assigned ahead of time, and any ripple effects of the operation flow downstream from the UPS can be managed much better. Okay, so planned maintenance is the goal. If you see on the right hand side, you want pretty much 80% planned maintenance and 20% breakdown maintenance. And you can see on this graph here, this is worst case scenario at the top, where we're doing 64 unplanned reactive hours and 36 planned. Therefore, we have a total of 100 hours being expended, and only 36% of those hours are planned work. Okay, and best case scenario with the 80-20 is when you have 53 hours of planned maintenance. So it's only an increase of 17 hours from this point here. But you've saved a huge amount of unplanned reactive hours. It's gone down to 13 from 64. Okay. And the total hours have gone down to 66 hours. So you're getting the same results, and you're only utilizing 66 hours of maintenance rather than 100. So it's a very interesting chart, that one. And it has to be remembered that the UPS is the last line of defense. If it fails, production must shut down in most cases. And the cost of that in some operations facilities, in some plants, some petrochemical plants, can be millions of dollars. I remember one of the plants here in Houston, it was a plastic producing plant. And if they had an unplanned maintenance event that caused the plastic to stop flowing in their pipes, the plastic went solid in their pipes, and all of the pipes containing that plastic had to be cut out and then new pipes welded in. That takes time. You have to get permitry in place. So the plant could go down for 2 or 3 days when they had an unplanned maintenance event. So it can cost millions of dollars in production if you have a UPS failure. Okay, so what are the most common failure modes with UPSs and electronics in general? Okay. Well, the first one is high resistance connections, and that can be from poor contact pressure, in other words, inadequate torquing of bolts. It can be from insufficient pressure in compression lugs, and what that means is that the lug has not been created, or what's the word I'm looking for, compressed correctly. You know, the strands of the wires going into the lug have either been cut. You can see this one on the left. That looks like a strand that should be inside the lug. So that's a poor mechanism pressure. And it could also be that, you know, this wasn't squeezed hard enough, and the wire strands are kind of loose inside that compression lug. So the connection between this lug here to the wires inside is not quite as good as it should be. And the other thing that this picture shows is you can get corrosion here, dirt and corrosion on the contact surface. So that can cause high resistance connections. And what do high resistance connections do? Well, what this picture shows you on the right hand side. This is a DIN rail mounted switch, and it had either a high resistance connection at the top here, where the lug should have been here, or it was even corrosion or dirt. I don't know what it actually was, but what it caused is that contact to heat up to the extent that it caused that amount of damage from heat. And as you can see, you know, if there was anything else close to that piece of equipment, that also could have got hot, caught on fire, and it could have caused the whole system to go on fire. So I don't know what the outcome of this was, but it's obviously definitely not a good situation, and I'm sure it caused some kind of outage on that piece of equipment. And the best way to find high resistance connections is to do a thermal scan. And all of the AMETEK SCI field service engineers who go out to the plants and perform regular maintenance all have a FLIR C5 camera as part of their standard equipment, exactly the camera that you see here. So every time we come out and do a PM on one of your systems, we do a thermal scan. And I'm going to show you two instances within the last couple of years where high resistance connections have been found. So you can see in this picture here, these are the AC capacitors on the output of one of our UPS systems. And there are two wires going to each AC capacitor, and they're connected with a push-on crimp. And everything looked okay from a visual inspection standpoint, but you can see from this picture that our camera pointed out that this connection here is actually at 96 degrees, 20 degrees above the average temperature of this whole capacitor bank. So we knew there was something wrong there. So what happened was the field service engineers shut down the UPS and made sure that there was all the energy had been taken out of these capacitors, and then did a closer visual inspection. And what he found was one of the connections on that capacitor, although it seemed like it was pushed on to the correct crimp terminal, it was actually slid to the side of it, and it was just making a very light connection, and you could see it was heating up. So he had to remove it and put it back on again, and everything was fine from that point there. But if that had been left in place, that would have heated up over time and could have caused something to go on fire. It could have been a bad situation. So that's why we do planned maintenance, to make sure we find things like this before they become an issue. And at the opposite end of that spectrum, this picture was taken on a startup for one of our UPSs. And you can see this is a choke or an inductor, and there's three because this is a three-phase system. I think this is on the output choke of this UPS. So there's three for each phase. It's 1, 2, and this top one here, 3. And you can see box 1 has a maximum temperature of 150 degrees. Box 2 is about 140 degrees. That's normal. For box 3, only has 94 degrees. So that inductor is not hot when it actually should be. And what we found was there was a mistake made in the connections of these chokes, either by the factory or when I think it was actually, you had to connect two systems together, two panels, because it was a large system, and the wrong cable was landed on the wrong place, which basically bypassed this choke altogether. And that was only found because we did a thermal scan on that system. So once again, by using an infrared camera, you can find things that you won't be able to find from with the visible eye, should I say. Okay. So the next thing that causes most electrical failures is dust. And the IEEE study showed that 18% of switchgear failure listed dust as the main contributing cause. And the common impact to current carrying equipment and systems exposed to dust and powder is electrical short circuits or arcing. Basically, the dust becomes conductive, whether the dust is conducted itself or when there's moisture or some kind of corrosive component in the air. They act together and allow tracks on a circuit board or something else to create a short circuit. And obviously that is not a good situation. And you can see the picture on the right. I think this is actually from inside a PC, to be honest, but you can see that the circuit board and fan is absolutely covered in dust there. So there is all sorts of opportunities for short circuits to happen there. And then on the left-hand side, this one here, this is what it actually should look like. So a lot of people underestimate the power of cleaning out an electronic system. But it is very important. And obviously, every annual PM from AMETEK SCI includes a thorough cleaning of the system to remove dust and debris. And we do, all of our guys, especially at the Houston office, they all carry vacuums with them. If one of our FSEs has to fly to your plant, then we may ask you if we can use your vacuum if you have one available. And if you don't, then we'll try and go to the local hardware store and buy a vacuum and leave it in that switch room when we leave, so it can be used next time we're there. But it is very important to clean out the system once a year to make sure that there's no buildup of dust. Now, the next reason why we perform PMs is because of relay failures. Every time the contacts of an electromechanical relay or contactor are opened or closed, there's going to be a certain amount of contact wear, because whenever you open and close a contact, there is going to be some arcing. You know, you can't prevent it. You're either making a circuit or you're breaking a circuit. And in doing that, there's going to be some arcing, and that will cause pitting and of the contacts, basically. And as you can see on the right-hand side here, this is the exact same picture of these contacts here after they've been in operation for a long time. And you can see that you can hardly see the copper, and you can definitely see the surfaces of these relay contacts are pitted now. They're not going to make a really good flush contact when they close. So as part of our annual maintenance, AMETEK SCI includes the replacement of all critical relays in your system, if applicable. And you know, that doesn't mean we replace all of the relays in your system on an annual basis. What it means is all the critical ones that are to do with the operation to keep your load circuits maintained on inverter, all of those will be replaced on an annual basis. And from those pictures, you can see why. The next thing that we have to take into consideration is age degradation of components inside the UPS. So the first thing that we have to look at is capacitor failures. And you can see here that this is what the capacitors are supposed to look like. And this bus bar is supposed to be going straight there. And you can see that this capacitor here has ruptured, and ruptured considerably with a certain amount of force that has bent that bus bar. We did not bend that bus bar. It was this capacitor failing that caused that bus bar to bend. And obviously, there could be some components that those bus bars get pushed into and could cause a short circuit in some circumstances. So you can see that this is not a good situation. So we want to make sure circumstances like this do not happen. And capacitor manufacturers, they list their anticipated life in hours. Okay, so our design engineers have to go in and then look at all the parameters of the capacitor manufacturer's details and say, okay, at what temperature do these hours apply? And what else? Other things like ripple and other things, all the design parameters are looked at to see, okay, what do we have to do to make sure we get the life out of these capacitors? Okay. And that can be voltage, temperature, ripple current, many other things. So if you operate the capacitor at temperatures above the maximum rated temperature, the life will decrease by half for every 10 degrees Celsius. So let's say the capacitor manufacturer says, okay, you're going to get a certain amount of, let's say it's 1,000 hours just for an example, if you operate the capacitor at 100 degrees Fahrenheit, well, if you operate that capacitor at 110 degrees Fahrenheit, you're only going to get 500 hours of life out of the capacitor, okay? And also the life of the capacitor can be increased by the ratio between the rated voltage and the actual applied voltage. So if you have a capacitor that's put on a system that is rated for 1,000 volts, but is only going to see maybe a maximum of 400 volts, then you can actually increase the life of that capacitor according to the manufacturer's data sheet. And basically, when all of these parameters were entered into the specs for our UPS systems, the capacitor life works out to just about 10 years, okay? So that is why we recommend our capacitors are replaced every 10 years. And once again, you can see that there are DC capacitors mounted here. There's actually 2 banks of them. And we can see here, ignore this. This is a resistor. It's actually the discharge resistor on the capacitor bank. So if you do power down your system, then it will discharge those capacitors for you to make them safe. That's always going to be hot. That's acceptable. But you can see that every single one of these DC capacitors are within what we would say the expected temperature. And that's the main way that we're going to find out if a capacitor is going to fail prematurely, is that it starts to heat up and it will be seen with an infrared camera. Okay. We just had a question asked whether the PowerPoint can be shared. Unfortunately, the PowerPoint presentation is proprietary. We do not mind you sharing the YouTube video. It has all the slides. You can fast forward, rewind, and do whatever you want. But the actual PowerPoint presentation, unfortunately, is proprietary, and we do not share that. But thank you for asking the question. So the next thing that we're going to look at is heat stress. And high temperatures cause over 50% of electronic equipment failures, according to a study by the US Air Force Avionics Integrity Program. So 50%, that's half of all electronic failures, are caused by heat stress. So it's extremely important that we maintain airflow in our systems, okay? And to do that, our design engineers go in and they have to work out what fans are needed, how much air movement is required to get the air out of our UPS systems and exhaust them out into the room and get them away from our electronic components, okay? And obviously fans have motors and they have lifespans. And once again, the manufacturers of fans list their life in hours based on many, many different specs. And we looked at these specs, and our fan life has been calculated at around about 5 years. So therefore, we always recommend that the fans inside our systems are placed every 5 years to make sure that the airflow in the systems is always maintained, and therefore all of the electronics within that UPS cabinet is not being subjected to heat stress, which, as we saw, causes up to 50% of all electronic failures. So it's a very important thing to make sure your fans and your fan motors are maintained. Okay. And age and temperature are major factors in PCB failures, in printed circuit board failures. You can see we have a printed circuit board here. And let me see. So down in this bottom right-hand corner, there's a DC electrolytic capacitor. And also there are some tantalum capacitors on this board here. They look like tantalums, and that actually looks like a tantalum as well. They are all age related, and basically we say they have a 10-year life as well at nominal temperature, which for our systems I think is 100 degrees Fahrenheit. So if the temperature of the system goes above 100 degrees Fahrenheit, then these capacitors will start to age quicker. So that's why it's extremely important to keep the airflow of the fans and to replace the printed circuit boards every 10 years. Okay. And obviously, I've went over the electrolytic and tantalum capacitors have 10-year lives, but faulty capacitors can seriously affect the operation of the UPS. They can cause the system in some circumstances to transfer to bypass, and once you're in bypass, you do not have battery backup. So if you had a power failure, then you would drop the load, which would cause an unplanned outage. So we want to make sure that that never happens. So that's why we have the time frame of 10 years to replace capacitors and PCBs. And what a lot of people don't understand is even switches need to be maintained. And when we say maintained, you'll see on the next slide what we mean by that. But basically, we mean they need to be exercised, especially the remote manual bypass switch, which you can see on this picture here. Okay. The actual switch barrel that we use is from a company called ElectroSwitch in most of our RMBSs. And this is a direct quote from somebody who works for ElectroSwitch. And they specifically state that many customers will, as a rule of thumb, operate or exercise the switches at least once a year. And they go on to say, as you know, our unique dual wiping self-cleaning blade and terminal interface helps maintain a low contact resistance over the life of the switch. So therefore, by operating the switch periodically, the customer would be cleaning off the interface from any dust, debris, or oxidization that may have formed on the surfaces. So, you know, if you go back to that relay contact picture that we showed you, whenever you move that RMBS from one position to another, there is going to be arcing. And what ElectroSwitch are saying is when you move those switch, there is a self-cleaning action, a wiper that helps keep the surfaces clean. And if you don't operate that switch, then what happens is, you know, most of the time the RMBS is going to be in the normal position. That's the way that it should be. So if you leave it in the normal positions for, say, 5 years, that means the bypass contacts are open. And when they are open, they are susceptible to things in the environment, especially corrosive things in the air. Sorry for the poor description there, but if you have maybe a little bit of H2S in the air or something like that that can attack the contacts, then that will cause them to have a high resistance. And then when one day after 5 years you move it to the bypass position, you may not make a good contact and you could in theory drop the load. That is why we always recommend that when you have an annual PM performed on your UPS, that one of the things that you must do is move the RMBS, the remote manual bypass switch, and clean those contacts. Okay, I know some people get nervous about moving an RMBS, but if you're doing it on an annual basis, you should never have any issues. And you know, the way that I look at it is, if you are expecting us to be there and you are expecting the maintenance to be performed, if at that point when the switch is moved, you do drop the load for some reason, then you have the right people there and then to try and figure out what happened and to make sure it doesn't happen again. You don't want that to happen at midnight on a Friday. And we all know nearly all problems in plants happen at midnight on a Friday. Don't know why, but they tend to always happen like that. So what are the recommended PM periods? I've kind of gone over them as I was going over the slides, but I'll show you what AMETEK SCI recommends. So the first one is an annual PM, or what we call a PM1. Okay, and here are all the checks that are performed by an AMETEK solid state controls field service engineer when he comes out to do an official PM1. Okay, so we check and record all the voltages and currents. We check the 480 input voltage for balanced currents into the charger bridge. We calibrate all voltage and current readings on the UPS with a true RMS meter. So whether they're analog meters or whether it's our digital display, we make sure that the values that we read with our meter are the same that are displayed on that system. We also simulate a full loss of power to the UPS to make sure that the UPS does not transfer and maintains load. In other words, if you lost all modes of power, all AC from your switch rooms to this UPS, then the system is going to go onto battery, and we want to make sure that the system will handle that without any issues. We also test the aux contacts and shunt trip circuits to make sure that the DC input breaker trips at the correct voltage. And that voltage for a 60-cell battery is usually 105 volts. So we want to make sure that the protection is in place if the battery goes below 105 volts, that breaker is tripped so we don't over discharge the battery and basically ruin the battery, and therefore you would need to buy a new battery. We test all applicable alarm set points to ensure proper alarming, and then we verify that they are set at the correct value and time delay, and we will make sure that they repeat at your DCS system in your control room. So we would appreciate it if our guys come out and we're testing the alarms, that somebody has a radio contact with the control room and asks, has this alarm come in and do you see it at the control room? We verify the free running frequency of the inverter to ensure it is within plus or minus 2% of 60 Hertz in North America. And that ensures proper sync reference to the bypass source feed. So basically, to do that, we have to remove the bypass supply into the UPS itself. We would put the system in the RMBS to the bypass position, and then we would run the inverter without any bypass to the UPS, and it would run at its own internal frequency. And we make sure that that is set correctly. We also test the over temperature thermocouples to make certain the inverter shuts down and seamlessly transfers to bypass when necessary. So we have thermal, I don't know why it says thermocouples, it's thermocouples. They're basically monitors that once you go above 90 degrees C on our heat sinks, then we will cause the inverter to shut down and transfer to bypass. We also have them on chargers and the static switches. We just make sure some of them will just alarm, some of them actually have actions that will shut things down, but we test them to make sure that they work. We verify that all the AC caps are functioning correctly by taking voltage readings across the capacitor bank. We test the ripple current on the battery to ensure that it's less than 5% of the ampere hour rating of the battery. That's an indication that some batteries are failing. And we do any other functional testing deemed necessary by the service engineer to verify proper operation. So basically, we go through your system with a fine tooth comb. For battery charges, we'll check your float equalize function. And if you have charges in parallel, it says we check the load share function. Now, depending on whether you have active or passive load sharing, in truth, if you've seen any of my previous presentations, you know that I don't particularly like forced load sharing. It can cause many issues to be perceived on the system when there's no issue there. What I mean by that is, it's very difficult to get two chargers to share the load, especially at low currents. So what we do to check the load share function is, let's say you have charger A and charger B, and charger A has all the current on it, then what we will do is we will switch off the AC input to charger A with the current on it and make sure the current transfers over to charger B. Another way we can do it is we can just go on to charger B and press the equalize button, and that will raise the voltage of charger B to a level above charger A, and we should see the current transfer to charger B. We don't necessarily need to see the two systems share. We just need to know that they're both online and have the ability to take the load if necessary. For inverters and static switches, we want to check the automatic transfer function, the alarm functions, the manual bypass transfer function, and then basically we want to make sure that all of the transfers happen with no interruption. Okay, and what we do is all of our FSEs have an oscilloscope with them, and they will capture those transfers, and we will be able to see the exact point of transfer and make sure that the voltage, the output voltage before the transfer, during the transfer, and after the transfer is not lost. Okay, so we can do that without any issues. And then obviously, if there's any critical relays that need to be replaced or pilot lights, then they will be replaced as part of the annual PM. So a PM1, it's quite in depth, and just make sure that your system, and obviously we do the thermal scan of the system as well. Just make sure your system is fit for service. And then that's all you have to do for the first 5 years of its life. And then on the 5th year, we would do a PM5, which includes everything in the PM1, but there are more parts that need to be replaced. And the most obvious of those will be the fans. The fans will need to be replaced. I think we replace all relays at the 5-year mark, and we also replace fuses as well. So at the 5-year point, it's fans, fuses, relays, and pilot lights. But everything else that we do in a PM1 is still performed. And then at a PM10, it includes everything in the PM1. It includes everything in the PM5. But then additionally, we replace all capacitors as well as the fans and alarm relays and all that kind of good stuff. And then we also recommend that you replace the printed circuit boards. So you do a PCBR. So in truth, we actually call it a PM10/PCBR. So at 10 years, we replace the capacitors, the PCBs, and everything else that we would do at PM1 and PM5. Okay. Now, I'm not a sales guy, but sales usually always wants me to put something in there to tell you what other things that we can do. So other services that are optional, when you do a PM, you can do a battery service test. In other words, a capacity test. You can do a system AC load test. We can actually test, we can put your system on bypass, and we can run the UPS while you're on bypass at your bypass switch, and we can test that, especially after a PM10, that the inverter will give you 100% load if necessary. And if your transformer in the old microfarad systems and the analog systems, if we have seen that the temperature of that transformer has been increasing over time, or we notice that there has been a considerable increase in the noise level of that transformer, then we can replace that transformer. Okay. A good question from Amit. The part replacement has to be considered based on commissioning date or supply date. We as a company always do it from the commissioning date. Okay, that is when we start the PM cycle. So from the day it was first started up and commissioned, that is when the time starts for the PM periods. So thank you for that question. Okay, so here is the equipment that every single one of our field service engineers carry with them. So they carry a Fluke 87, they carry a Fluke 190 oscilloscope. It's just a dual channel oscilloscope. We carry a Fluke i410 amp clamp, a FLIR C5 camera, and at this moment in time, we are using laptops to connect to all of these devices, but we are going to be moving over the next year or two to iPad Pros. We are in the process of changing over to iPad Pros to make the maintenance go smoother and easier. But that is the minimum of equipment that our guys carry most of our guys carry more than 1 amp clamp, but that is the minimum that they carry. And, you know, the oscilloscope is extremely useful when doing maintenance, because it can find things that sometimes you wouldn't find without being able to see it on an oscillograph. So, you know, this picture here shows you the charger output before it goes into the filter. And there are some circumstances, especially if there is a loose connection to one of the SCRs, that waveform there might be missing. And then we go 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5. That one there would be missing. Okay. In truth, that wouldn't affect the DC output voltage of the system. It's only when full load current would be required that these missing pulses would start to cause an issue. But if we look at it with our oscilloscope, we can see straight away that that is missing, and we can say, okay, it looks like there's a gate lead loose or missing from one of the SCRs on the rectifier bridge, and therefore we can replace it before it causes any issues. And we have seen that multiple times. We have seen either, especially on startups, because our systems are transported over ground, and unfortunately we all know that the interstate highway systems in the US is not what it quite used to be. So they do get shaken around a little bit when they're going on ground transport, and loose connections can be exposed. So an oscilloscope is a very good way to see that. We can also see a very good picture of the synchronization between the bypass and the inverter. It's difficult to see here, but there's actually 2 waveforms there. The red one is a little bit lower in voltage, that's the inverter, and this blue one here, that's the bypass voltage. And we can see that there is only -4 electrical degrees between A and B, and that's completely okay. We can say that that is a very good synchronized signal. Okay. We've had another question. Did you hear correctly that UPS AC load tests are recommended after PM10s have been performed? Is it recommended? It's the same with anything, Rick. There are additional costs involved, and it depends how reliable you want your system to be. You know, there are things that can, I suppose, go wrong when you change all of the printed circuit boards within a system. It's very complex electronics that are involved. So if you want absolute reliability, then yes, it's absolutely recommended that you do an AC load test after a PM10 PCBR has been performed. It just gives you that warm and buzzy feeling, excuse me, that the system is going to perform as designed. It should do. You know, the way that our PCBRs changeouts are designed, especially if it's done by one of our service engineers, is it shouldn't have any issues. But especially on our old analog systems, there are pots, potentiometers involved, and they have to be set up correctly. And some of those potentiometers are for current limit settings, and they can't be tested unless you test the system with full current to make sure that they go into current limit when they're required, especially on the DC side. So if you want full reliability, then definitely doing an AC load test after the PM10 PCBR has been performed will give you that knowledge that your system can supply full load after the maintenance has been performed. Hopefully that answers your question. And then I mentioned earlier with our oscilloscopes that we capture the exact transfer point between inverter to bypass and bypass back to inverter. And how we do that is we put an amp clamp on the output of the system. And on this circumstance, if we're transferring to bypass, we will put the amp clamp on the bypass supply. So in normal operation, which is this portion here, we should have no current flowing through the bypass amp clamp because we're on inverter. But as soon as the amp clamp sees that there is current flowing through it, that means there is current flowing through the bypass, we know that that is the exact point somewhere between here and here where the system transferred from inverter to bypass. And we can see that the sine wave, the red sine wave here, this is the sine wave of the inverter, and this is a sine wave of the bypass applying load, because we're actually monitoring that on the output of the system. So you can see that there was no blip, dip, or anything happened to that voltage when the transfer took place. And that's exactly what we're looking for. If we'd seen that this whole portion of the sine wave had gone missing when the transfer happened, then we know that we would have an issue. You know, if we saw that that sine wave went straight over to there, then we have a whole pulse missing, then that's not good. And we would troubleshoot further to see what is happening. But that is why we capture the transfers with an oscilloscope, so we can prove to you that the system transferred seamlessly. Okay. And then with the Fluke 190s, what we can also do, if absolutely necessary, if we think there is some kind of electrical distortion on the output of the system, we have the ability to check the THD, the total harmonic distortion of the output waveform. So you can see on the left-hand side, the red waveform is the output voltage of the system. And then the Fluke software has the ability to go in and use a spectrum analyzer on that system. And therefore, we can look at the harmonics involved. And if you look on the right-hand side here, we can see that the THD for that waveform is 1.17%. And that's well within the specs of the system. So, you know, our oscilloscopes are very, very good. And the other thing is they're isolated channel oscilloscopes. So we can monitor different values to ground because they have no reference to ground on each channel. Be very careful if your guys are using non-isolated oscilloscopes. That can go very badly. You don't want to do that. Somebody has asked, is the risk worth it to simulate a total power loss just to see if the UPS will pick up the load? Michael, it's a good question, but you know, why are we performing maintenance? We want to make sure that the UPS is fit for service. Would you rather that you found out there was an issue at 10 o'clock in the morning on a Thursday when you knew maintenance was being performed, rather than midnight on a Friday or Saturday night when everybody's rushing around and the plant has to be shut down? It's a call that everybody has to make. You can do it when you have the system with the RMBS in the bypass position. Obviously, there's no load on the system, but it would prove that with all AC power to the UPS isolated, that the system will run on batteries. It just won't be drained at the same level that it needs to be if you were on normal load. But you know, it would be good to do that test. I maybe wouldn't remove the bypass if I was doing it on a live system, because if you remove the AC input to the UPS and it goes on battery and the batteries do fail, then we want to make sure that we can go to bypass if necessary. So I understand your point there. But I do understand your question there. And that is his statement was, I wouldn't be the one explaining that I tripped the plant doing a test. And you're right. That is the most nerve-wracking thing about working on a UPS, is that you could trip critical load circuits while doing it. But what I always tell people is, you know, if the UPS is functioning correctly, you will not trip the plant. Simple as that. If it's working correctly, then the system will not trip your load circuits. It's only if something is not working correctly that there is a possibility of tripping the load circuits. And therefore, you have to find out what that problem is. These are things that you have to decide before we come out and do the maintenance. And I just wanted to quickly add on here that our field service engineers, they all conform to NFPA 70E electrical safety rules. We use category 2 PPE, especially when we go to the new iPads. There's a new risk assessment that they have to perform that says that they specifically have all this equipment and will wear the correct equipment when working on live voltages, because safety is our #1 priority. And another thing that I wanted to mention is if you perform the required maintenance on your AMETEK systems using an AMETEK field service engineer, then the benefits of that is you will get a full bumper-to-bumper parts warranty. Okay, so let's say your UPS is 4 years old and you're performing regular annual PMs, and for some reason the main PCB control board fails. Okay, that could be upwards of $6,000 to $10,000 worth of control board. If you are performing your regular AMETEK maintenance, then that control board will be free of charge. Okay, it's a full bumper-to-bumper parts warranty that you get when you perform the scheduled maintenance as per the AMETEK maintenance schedule. Okay, labor is also covered. Travel and living is charged at cost to you. And also the emergency service fee is waived. We do, if you have a breakdown and you don't perform the regular annual maintenance, then we do have an expedited call out fee, because we do have to move around our schedule and upset other customers to go and help you. So there is a service fee that's usually put on to cover that. But if you perform the regular annual maintenance, 5-year maintenance and 10-year maintenance, you get full bumper-to-bumper parts warranty, your labor is covered, and the emergency service fee is waived. All you will be charged is a travel and living costs. Okay, but you must follow the recommended PM schedule to maintain the warranty. If you miss a year, then you will not, the bumper-to-bumper warranty will not apply. If you then go back onto the PM schedule after that year, then yes, you will go back onto that warranty. Okay, but it's, you know, many people don't realize that they see that our maintenance, our PM maintenance costs do seem high to some people, but you're getting a factory trained engineer who knows what he's doing, and we're backing that up with a full bumper-to-bumper parts warranty. So the costs are all built in there. You don't have to worry about parts costs of breakdowns if that happens while you're under the recommended PM schedule. Okay. And there's the benefits of a comprehensive service agreement. So if you do the maintenance, that's good, but you can also have what's called a CSA, a comprehensive service agreement. And then there's, I'm going to leave this up there. You can look at the YouTube channel or any of our brochures to see what that offers. I'm not, like I said, I'm not a salesman, so I'm not going to try and sell you one of those, but they do give you a comprehensive coverage. You don't even have to pay hotel and living costs for a breakdown warranty if you have a CSA. Okay. And the one last thing that I wanted to go over is we do have the ability to use Help Lightning, which really helped us out during the pandemic. Whenever somebody had an issue and we really needed to get in front of the UPS, we can use Help Lightning, which is a merged reality application. And basically, you know, you can hold your phone up in front of the UPS and we can see on our either our iPads or our PCs, we can see what you're looking at, and we can actually put our hands onto your screen and say, can you check this? Can you check that? We can circle things. We can draw arrows to show you where we want you to check, or which button to press, or what LED to check, is very, very helpful for remote support. And we have been using it a lot during the pandemic. So it is available. Obviously, we do know that there are issues with connections in switch rooms, and you don't have a good either a Wi-Fi signal or a cell phone signal, and therefore it makes it very difficult in those circumstances. But if you do have a good signal, then we really can help you out using this merged reality help lightning app if necessary. Wow, look at that, exactly 11 o'clock, and I get to any questions. It's amazing. Let me see if we have any questions. Is the risk worth it to simulate a total power loss? Okay, he's already asked that, so that's fine. That was in the Q&A. Let me see if there's any other questions that I have missed while I go through there. Is there a recommendation when the transformers get replaced? We have had transformer failures. That's a very good question, Scott, and that's once again one of the reasons why, if you do annual PMs, we should see that there is a transformer failure coming. Because obviously we do a thermal scan and we can see year over year if the temperature is increasing. And that's the biggest telltale sign that a transformer is going to fail, is the temperature. And if we see that, then we will recommend that the transformer is replaced prior to it failing. The other thing is, audibly, if we hear that it is much louder than it should be, then that's another indication that the transformer should get replaced. There is no time frame for when we recommend transformers to be replaced. You know, there's transformers that are still out there that are 40 years old that are working absolutely fine. We just, as a company, we've never thought it necessary to give you a specified time as to when the transformer should be replaced. It should be based on all of the information pointing towards that it may have a failure. And I suppose it's the same as oil field transformers. You know, you do your tests on the oil, you do all your tests to make sure that it's okay, to help prevent a failure. And that's the same with that. That's why we do the thermal scans. What other questions do we have? We have dual charger systems. Do both chargers share equal load or work in lead lag rate? Can we choose or change? It depends. Once again, load sharing on chargers is one of my biggest bugbears in the whole industry. But we do have, on our new digital chargers, you do have the ability to have forced load share. That only came out in the last year or so, I think. Before that, it's what was called passive load share. So, you know, it's set up when you first commission the systems, but it can drift, and it will tend to always drift, especially on low current. So it's very difficult on a passive load share to actually get chargers to share the load. On the active load share, it is supposed to work quite well. But once again, I think the specs say you have to have at least 5% of the total current on the systems for active load share to work correctly. So if it was a 100 amp charger, you would need at least 5 amps on both chargers, I think it is, to make it work correctly. So to be able to change it, no, you would have to get a new control board with the ability to have the active load sharing on it. And I think, I can't remember if you have to have a LEM current transducer as well. I'd have to check into that. But my point about load sharing is, all you need to know is that both chargers are available and on. And like I said, just press the equalize button. If there's no current on one of the chargers, press the equalize button. If you start to see current on that system, then the system's fine. And the reason why I say on low current systems is because a lot of the people who ask this question have parallel chargers connected to their switchgear. And their switchgear systems, although they'll have a 100 amp charger on it, all that you're keeping powered is a very small amount of trickle current to the battery and some auxiliary power to some lamps on the switchgear. There's a very light load on switchgear systems. So that is very, very difficult to get switchgear chargers to share the load. Okay, hopefully that answered your question. Does firmware version to charger screen require to be upgraded if you have two chargers with different firmware? That's a very good question. In some circumstances, yes. If the firmware versions are very wide apart, then they may need to be changed, especially if they have the active load sharing. In fact, with active load sharing, I would think they would have to be the exact same firmware version. But what I would do is get in contact with your service representative for your area and ask that question, and they will get back with the exact answers. You know, send them a screenshot of the firmware version for both chargers that you're mentioning, and they will let you know if those firmware versions are good. And that actually leads me to another point. You know, when we do our maintenance on the systems, those are the kind of things that we will check and we will comment on that when we're out in the field. And obviously, if there is a firmware update that is absolutely necessary to be done, then our field service engineers will be able to do that while they're on site. So another good reason to use an AMETEK field service guy. There's no more questions coming in that I can see. Brooks just put in there, thank you very much, Brooke, that you will receive a follow-up email tomorrow with a link to the recording on YouTube and a follow-up survey. Once again, please do fill out the survey. I don't get, you know, my bosses don't get to see the surveys. That they can if they want. Nobody's looking into it to see whether I'm doing a good job or not. What we want to know is what you want me to discuss at the next webinar. That's, I think it's question 5. What would you like us to discuss? Please fill out that question, whether you want more information on inverters, IGBTs, or the different styles of chargers that are out there, or anything. You know, let us know what you want, and we will try and arrange for one of the future webinars to answer the questions that you want. Also, Brooke has put in there, if you need any additional help, you can reach out to sci.sales@ametek.com. If you send an email to there, it will be routed to the correct person, and they will reply to you as soon as they can. So if there's no more questions, I would just like to take the time to thank you very, very much for taking time out of your busy days and watching this presentation on PM schedules for AMETEK SCI UPSs. We really do appreciate you coming and listening to me talk for an hour. My wife says it's very impressive for anybody to last more than 10 minutes. So I really do appreciate you coming along and listening and taking part. Asking the questions is the most important thing. It really is appreciated that you're interacting with us. And if you want to know any more about our service packages, you can click on the link that Brooke just put in the chat bar as well. That takes you to our client support and services webpage. So until next time, please do take care. Don't hesitate to get in touch with us. You can go to the AMETEK website and get our 1-800 number as well. You can contact us via email. We will do everything we can to get back to you. It's been a pleasure as always, and I will speak to you next month. Take care until then.